Alright, so in this video, I'm going to solve the problem 2 to the power of 25 minus 1. So, to first start, I'm going to rewrite 2 to the power of 25 as 2 to the power of 24 plus 1. And then we have our minus 1 at the end. And the reason I'm doing this, and rewriting 25 as 24 plus 1, is so now I can use the property a to the power of m plus n is equal to a to the power of m times a to the power of n. So 2 to the power of 24 plus 1 is going to equal 2 to the power of 24 times 2 to the power of 1 minus 1. Now basically our goal throughout this video is to change our values to be as small as possible, so then at the end we can do whatever we need to do with them to get our final result. So 2 to the power of 24, how do we simplify this and make it even smaller? I can rewrite this as 2 to the power of 12 times 2. And another property of exponents is that if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 12 times 2 is going to equal 2 to the power of 12 to the power of 2. And I have this times 2 minus 1. So now I'm actually going to plug in the actual value of 2 to the power of 12, because 2 to the power of 12 is small enough where we know the exact value of it. So if you guys don't know what 2 to the power of 12 is, well, 2 to the power of 10, you should always remember this as 1024. So 2 to the power of 11 is going to be double of 1024, which is 2048. And 2 to the power of 12, which is the value we're looking for, is going to be double of 2048, which is 4096. So now I get 4096 squared times 2 minus 1. And now this is equal to, I'm going to simplify this, 4,000 plus 96 squared times 2 minus 1. And the reason I'm doing this is because 4096 squared is really hard to calculate by itself. So if we change it to 4000 plus 96 squared, I can use the property a plus b squared is equal to a squared plus 2ab plus b squared. So in this case, a is 4000 and b is 96. So this turns into 4000 squared plus 2 times 4000 times 96 plus 96 squared. And I have all of this minus 1. Oh, sorry, all of this times 2 minus 1. Now, 4000 squared is equal to 16 million. 2 times 4,000 is 8,000, and 8,000 times 96 is equal to 768,000. And now I have this plus 96 squared, which is equal to 9,216. And all of this I have times 2 minus 1. So now I'm going to add all these up. So if I add all of these up in the parentheses, I get 16,777,216. So now I have this times 2 minus 1. So if I multiply this by 2, I get 33,554,432. And I have this minus 1, which is equal to 33,554,431. So this is my answer to this problem. Alright, so in this video, I'm going to be solving the problem 100 to the power of x is equal to 10 to the power of x plus 1 to the power of x. So, to solve this, what I'm first going to do is rewrite 100 to the power of x as 10 squared to the power of x. So now this is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of n to the power of m. So 10 to the power of 2 to the power of x is equal to 10 to the power of x to the power of 2. So now I have 10 to the power of x to the power of 2 is equal to 10 to the power of x plus 1 to the power of x. Now, if I have something in the form, 1 to the power of any number is just going to be 1. So we can just get rid of this x as an exponent because it won't really change anything. So now I have 10 to the power of x squared is equal to 10 to the power of x plus 1. And now from here, I'm going to let 10 to the power of x equal to the variable m. So now I have m squared is equal to m plus 1. And this turns into m squared minus m minus 1 is equal to 0. Now I'm going to use the quadratic formula to solve this. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get m is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4a which is 1 times c, which is negative 1, all over 2a, so 2 times 1. And this turns into positive 1 plus or minus the square root of plus 4 over 2, which is equal to 1 plus or minus the square root of 5 over 2. So this is the value of m. And to be precise, the two values of m are 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. Now, remember how we let m equal 10 to the power of x. So 10 to the power of x is equal to 1 plus the square root of 5 over 2, and 10 to the power of x is also equal to 1 minus the square root of 5 over 2. So for my second equation over here, 10 to the power of x is equal to 1 minus the square root of 5 over 2. Well, 1 minus the square root of 5 over 2 is a negative number. And you can't take the power of a positive number and make it equal negative, meaning there's no solution to this equation. So we are only left with 10 to the power of x is equal to 1 plus the square root of 5 over 2. And to solve this, I'm going to take the log on both sides. So I get log 10 to the power of x is equal to log 1 plus the square root of 5 over 2. And if I have something in the form log a to the power of b, I can move the exponent b to the front, so this turns into b times log a. So now I have log 10 to the power of x, which I can move x to the front, so I get x times log 10 is equal to log of 1 plus the square root of 5 over 2. And now I'm going to divide both sides by log 10. So then these two cancel out, and I get x is equal to log of 1 plus the square root of 5 over 2 over log 10. And log 10, if you guys already know, is equal to 1. So this turns into log of 1 plus the square root of 5 over 2 over 1, which is the same thing as log of 1 plus the square root of 5 over 2. There's no need to include the over 1 because anything over 1 is itself. So this is my solution to this equation.